Hello everyone, myself Dr. Jyoti Chandra, Assistant Professor, Department of Chemistry, Patna Women's College. Today I am going to discuss about the state of matter. Let's start with the basic concept of the state of matter. What do you mean by a state of matter? A state of matter is one of the ways in which matter can interact with itself to form a homogeneous phase. Now, what is homogeneous phase? Homogeneous phase is a single phase that can be either solid, liquid or gas. A state of matter can be classified on the basis of two states, physical states and chemical state. On the basis of physical state, matter can be classified into three phases. First solid phase, second liquid phase and third gaseous phase. First, we will discuss about the physical properties of solid. Let's see the figure here. In figure we can see that the particles of solids are closely packed. Why this is closely packed? Why not loosely? Because there is a strong force of attraction between the particles of solid so that particles cannot move freely but can only vibrate. As a result, solids has a stable, definite shape and a definite volume. The particles of the solid have the minimum kinetic energy as they are closely packed. Due to this, solids have the most orderly arrangement of particles. Solid can be transformed into liquids by melting, liquid can be transformed into solid by freezing, and solid can also change directly into the gases through the process of sublimation. Now, we will discuss about the physical properties of liquid. From the figure, we can see that the particles of liquids are not as close as in solids. Spaces between the particles of liquids are more than in solids. So, we can say that the particles are loosely packed in liquid. The force of attraction between the particles of a liquid is not strong enough to keep the particles in fixed position. So, the particles of a liquid can move from one position to another within the liquids with more kinetic energy than the particles of a solid. Due to this, liquids have a more disorderly arrangement of particles than solid. Now, the physical properties of gases. Here in figure, the particles of gases are much far away from one another as compared to solids and liquids. Why they are far from one another? Because there is no any force of attraction between the particles of gaseous molecules. So, the particles of a gas moves with higher speeds in all directions. The position and spaces between the particles of a gas are not fixed. When the fast moving gas particles hits the wall of the container, the exert pressure by a gas is due to the collision of the fast moving gas particles against the wall of the container. When the gas is put in an empty container, it quickly spreads throughout the container and fills it completely. If a gas is heated, the particles of gas start moving faster and faster. Now we will focus only on the liquid state. Liquids show different properties and behavior. Here we will learn the different behavior of liquid state. First, volume and shape. The particles in a liquid are attracted to each other. This keeps the particles close together and take the shape of container in which they are kept. This is why liquids have a definite volume. Second, compressibility. Liquids are largely incompressible. It is because there is very little empty space between the molecules. In contrast, the gases are highly compressible because of large empty spaces between their molecules. Third, diffusion. Diffusion is the process of a spreading of a substance from a region of higher concentration to a region of lower concentration. Diffusion is more in liquid. Next, evaporation. Evaporation is the process by which a liquid changes into vapor. Why liquid changes their phases when we increase the temperature? This is due to weak intermolecular force of attraction between the particles of liquid molecules. Last, vapor pressure. When we heat the container filled with liquid, its walls are occupied by the vapor from that liquid. As soon as the temperature rises, liquids turn into the vapors. These vapors exert the pressure on the wall of that container, and that exerted pressure is known as the vapor pressure. Initially the vapor pressure increases, but after some time it becomes constant. Gradually an equilibrium is established between the liquid phase and the vapor phase. The vapor pressure at the point of equilibrium is known as the equilibrium vapor pressure or saturated vapor pressure. The whole phenomenon of vapor formation depends on the temperature, and hence when we increase the temperature, vapor pressure tends to increase. We can say that the vapor pressure is directly proportional to the temperature. So, in next lecture we will discuss the surface tension and viscosity. I hope this lecture is useful to all of you. Thank you.